And now moving onward and forward. So the title of the next presentation is How IPFS is Designed to Replace HTTP. The unique use cases decentralized storage is powering. So I'd like to warmly welcome Lukas Bresser of Protocol Labs.
Hello, hello. Hi, everyone. Still waiting for my microphone to work. It works now. And my slides are going to come up. Yeah, I am Lukas. I work for Protocol Labs, which is the company that first developed IPFS and Filecoin. And I'm here to tell you a little bit about those two protocols. Once this is out of the way. Okay, anyways, like once the slides are up, just give me a shout. I want to really get you excited about two things. One is the idea of content addressing versus location-based addressing, which is super critical to, I think, like the D-Data Summit, right? Decentralized data, that won't work without content addressing, and that's what IPFS does. I'll tell you a little bit about what that is in a second. And then Filecoin, which is an off-chain data storage solution that is the largest decentralized storage network, so that now has, I think, 19 million terabytes of capacity. So that's the one that, I don't know, like happy to chat, like, and I want to leave room for some questions at the end. But yeah, that's the one that I'm excited about, and I think that's the only one that really reaches the scale that would allow us to compete with, like, the Web2 centralized solutions. Can I help anything with the slides? I'm not really. You want to just, no. Or should I send it to you as a link? Let's see. Do you want a link? Would you prefer a link to, like, or not really? No? Should work. Extend. Mirror. Okay. Who knows IPFS? Like, who's heard about it? Okay, great. That's awesome. So I can already, like, keep that short. Who knows how IPFS and Filecoin are different? Kind of? Okay, great. Great. I'm going to answer all those questions. And who's annoyed by the idea that IPFS isn't permanent and thinks that's like a major flaw of IPFS? Great. Awesome. I'll tell you why I don't think that should be a concern to have. And I will do all that once the slides are up. Yeah, I don't know. I can send you slides if you want. Here. You just want to go to? Oh, there you go. Sure. Yeah. I'm thinking what I can tell you while without slides. Who's used IPFS? Like, who's actively using it? And cool. How did you start your, like, how are you using it? When did you start using it? Maybe I can tell you what I do. So for IPFS and Filecoin, I run what we call the builders program. So my role is to get all of the builders in the room, and I hope there are some excited about building applications on top of IPFS and Filecoin. So I'm always curious how people found their way. Like, how did you hear about it? Or when did you start building with IPFS? Just curious. Yeah.
So people need to be able to get my DAP, and I use DNS to register the domain, and then people need to be able to access my DAP.
Great, and so you're addressing it with IPFS? Oh, there we go. Now we have slides on that screen. I think we're just, sorry about that, yeah. Great, cool. Full screen. Okay, cool. I can't control those slides. So is the screen like... Oh, I'm sorry, guys. This is quite annoying for you all. Anyways, can you help me like move this? I can't like control that screen. Let me try again. No. Like what I see on my screen is not what I see on that. There we go. Okay, cool. You got it? Okay, I'll just try. Okay, here's me, introduction to IPFS and Filecoin. I work for Protocol Labs, and I'll talk to you about IPFS and Filecoin. Think of IPFS really just as a version of HTTP. Don't think of it just yet as a decentralized storage solution. It's just a way to reference and address data. And then Filecoin, please do think of that as a decentralized storage network. And you can kind of think of it as like an Airbnb for storage. I'll talk about a couple of things. I'll talk about IPFS and Filecoin, how they're different, how they're similar, or how they're related. I'll briefly go through some tools for builders, talk about some of the exciting use cases that exist, and then maybe share some learning resources, and hopefully we'll still have some questions for Q&A. So the internet today is really nice, but also really bad because you have these centralized points of failure where very few companies like Google, Amazon, Microsoft control a lot of data, and if those services are down, we can't access our data anymore, right? So a couple of examples here: data breaches, AWS goes down when everybody wants to watch the latest, what's on there, Lord of the Rings, the new one, or companies selling data on your behalf that is actually your data. And we're all here to see if we can move ourselves collectively over to the left towards a future where maybe it's more decentralized and ultimately, hopefully, completely distributed, where users power the services, not like large companies, a web that's more censorship resistant, has kind of privacy built in, allows you to self-verify whatever data you're accessing, and where all that data is like busting all the data silos that exist and are going back into kind of users' hands. IPFS is like one piece of that, and Filecoin is another. IPFS just stands for Interplanetary File System. A file system is something that's like files and folders, what you know from your computer. And interplanetary, it's called that because it is distributed and resilient offline first. Like this little graphic here shows how it kind of in theory will, or not in theory, like completely in practice works. If somebody on Mars accesses a piece of data, their first request will go down to like an IPFS node on Earth where the content is stored, but then every other person that's requesting that same piece of information can just request it from the person that already received it on Mars, right? So you're saving your like all the way going like one more ping basically back down to Earth. How does that work? IPFS addresses content by what it is instead of where it is. And this is super, super critical, right? So if you think about how we address data or anything really, like think about how you address a book or identify a book, you identify it by its title, right? You identify it by what it is, what it describes. You don't identify it by where that book is, right? If I tell you, oh, you should read this book, I don't tell you, go to my bookshelf, third book from the top, second row. That's silly. That's not how humans address data. And IPFS helps you do the same thing, just with files. So it replaces a folder, a location, with a content identifier, right? So you know how paths work today. You have like a file somewhere, or you have a domain, and that points to a specific physical location in the real world. With IPFS, you're pointing to a content identifier, and that piece of content can be in any number of places, and any number of places can serve that content back to you, right? So that's content-based addressing as opposed to location-based addressing. How that works is pretty straightforward. Actually, you have a file, then you hash it. That gives it kind of a content identifier, which you can think of a kind of like a fingerprint of that file. So if you have the same content and you run it through the hash function, it will always have the same identifier. There's no, like if even one byte is different, the content identifier will be completely different too. So what you can now also do is like once you receive a file, and you have it on your computer, you can just run the hash function again, and you can verify that the content that you received is actually the content that you requested. We call that verifiability. So that's location-based addressing. I'll skip through some of these things a little bit quicker because all of this is not super important, or it's important, but I'll just keep it simple. So now there's big problem with IPFS, but it's not permanent, right? That's kind of a bad thing, and people kind of don't like it. That's not what IPFS is meant to do, right? So IPFS is just a way to address and retrieve and route data on the internet. How that looks like in the wild is kind of like this, right? So you can either run your own IPFS node, which is very much like in Web 2 when you host your own web server, or like Web 1.0. That's kind of difficult, it's complex. You can do 1B, which is run your own network of nodes, where you basically operate an infrastructure of IPFS nodes to make sure that your content is retrievable in a reasonably performant amount of time on the other side of the globe, or when you turn off your computer. You can also pay what's called a pinning service. Pinning is just another word for hosting on IPFS, right? So if you host a file on IPFS, you don't say you host it, you say you pin it. And there's Infura, there's Pinata, there's Temporal. There's a bunch of services that basically offer pinning stuff for you on IPFS, so you don't have to do it yourself. Or the third option is that you can basically hope that your content becomes popular enough that it's replicated by different peers on the network. But none of these services are really give you a guarantee, right? Like in 1A, 1B is super complex, and you have to do it yourself. With option 2, you have to pay a provider, and very much like in Web 2, you're paying them to, you're signing some SLA, and they're ensuring some kind of, availability of those files, but it's still a trusted relationship. It's not trustless. And with 3, you're kind of on a little bit of wonky legs, right? Because who knows if your content is popular enough? What if at some point all these people choose to no longer pin your content to the IPFS network? That's where Filecoin comes in. So that's kind of the decentralized and reliable alternative. It is compatible with IPFS and Web3. So it uses this idea of content-based addressing and then builds kind of persistence guarantees around it. And it does that by using cryptographic proofs. And that's kind of a carrot and a stick. So you have storage providers on the Filecoin network that get paid for storing your data, and they're constantly verifying that they're doing that. That's the carrot, and there's block rewards for that and just straight up storage deal revenue. And then there's a stick, which is if they can no longer prove that a given file is around, they lose a lot of collateral. So it's always economically rational to actually continue proving that you have the file if your kind of deal says it. And it's massive, right? So it's actually 19.5 million terabytes of capacity, which is about 1% of total global cloud storage. I think it's about a 10th of, or maybe a 20th, I'm not quite sure. You can check it out on storageindex.io, of all of AWS capacity. So we're in territory where you're actually reasonably competitive in terms of capacity with some of these major cloud providers. And it continues to grow at a very fast rate. The cool thing is, it's governed by consensus, right? So it's not one single corporation. In fact, there are 4,000 storage providers on the network, not just one, or in AWS's case, I think they have 35 data centers across the planet. But 4,000 obviously gives you a lot more redundancy. How does it work? I'll just double click into this really quick. So one of the building blocks is the Filecoin storage deal, which is basically going through these steps where first you make a deal with a storage provider, or a smart contract makes a deal on your behalf. Then that storage provider proves that they have received the file. Then step 3, over time, they kind of continuously prove that they still have the file, and they unlock kind of block rewards, and they get incrementally paid in the native token, Filecoin, and they're penalized if they can no longer provide those proofs. And then at the end of the storage deal, you can either retrieve the file, or you can let the deal expire, or you can renew the deal. So what that gives you basically as a building block is you can build towards permanence, right? So by in sequence, over time, just making more and more storage deals of the same file, you can build perpetually into the future towards a permanent data storage solution. And you don't have to do that yourself, right? You can just fund a smart contract or endow a smart contract to do it on your behalf. And then, of course, you can stack any number of Filecoin storage deals on top of each other to build towards redundancy, right? So in the unlikely case that one storage provider does no longer provide the proof that they're storing the files, you still have any number of backups of that file on the Filecoin network. Cool, and then just to be super clear, so IPFS is just a way to address data. It's completely agnostic with regards to what storage layer it uses. So you can use IPFS with Arweave. You can use IPFS with Filecoin. You can use IPFS with AWS, right? Like it doesn't care. It's just a way of addressing the data. And Filecoin, I think, is the most compelling, like actually decentralized solution, just around what I talked about in terms of capacity, performance, etc. So that's kind of how it works. Those are the key concepts. Summary, right? Like IPFS for retrieval, and then Filecoin for persistence and verifiability. Cool. Okay, I'll let this sink in. Like location addressing, and then the persistence guarantees. Now let me just click through these quickly too. So if you're a builder, dealing with these protocols, dealing with IPFS and Filecoin is fundamentally hard, right? Like those are complex protocols. So what exists to make that easy is all these developer tools that we've developed and that other people are developing. We call them storage helpers. What they allow you to do is basically pin something to IPFS and Filecoin with a single call, and it simplifies all that complexity, abstracts away all of that complexity, so you don't actually have to go out and find a provider. These storage helpers will do it for you, which makes your life a lot easier. So I encourage you to check those out. I'll just put a few out there. Fleek for websites, Web3.storage, just general purpose storage. NFT.storage is for NFTs, right, used by OpenSea. Many of the largest marketplaces, regardless of what chain, are using NFT.storage to store their NFTs. Powergate, there's a lot more. This is what I do, the possibilities. Maybe briefly into use cases, right? So, because I think some of the panels earlier were like the future is still quite far, not sure when we'll actually have decentralized data storage, when can we use it? We actually can totally already use it, right? So there are a bunch of cool use cases that are using IPFS and Filecoin. There's Huddle, which is kind of like a Zoom clone, but works with IPFS and libp2p, another networking protocol. Audius is kind of like your Spotify version of Web3. And there's a bunch more. I'll click through these quickly. NFTs, obviously. NFTs are, I think they're cool, like the little cartoon images, but I think what's really interesting is just thinking of NFTs as digital objects, and then they can be tickets or they can be anything. And if they're really large, you need to find a way to store them in a way that's not prohibitively expensive. Storing anything of a reasonable size on-chain is prohibitively expensive, so you really have to, the only way to do it is you have to address it with IPFS and then ideally store it in a decentralized way. And then there's a lot of consumer products, right? Think you're a decentralized version of Google Drive or Dropbox or something like that. Like one that that's not actually on here, maybe there's a second page, there is, yeah. Chain style files very much feels like you're using Google Drive, except you're using IPFS and Filecoin and you're not actually trusting your data with any of these large data monoliths. Cool, and then finance and biotechnology. There's really a bunch of interesting things that's already stored. And then the Filecoin network actually already stores 160 petabytes of data today. And some of the ones that you might know is the Internet Archive, so the Wayback Machine stores its entire data on the Filecoin network as a backup. And there's many more, like climate data, which obviously benefits a lot from having immutability and some of the other features that I talked about earlier. Cool. That's the end of my talk. If we have a moment, I'd be happy to answer a few questions. Yes, in back.
Can you go back to the slide regarding NFT storage? Because I did not
Yes. Yes. I'll pull it up. There we go. Oops, sorry. Here we are. Oh, you want to take a photo? Yeah.
And I would like to hear...
Yeah. Oh, you want me to talk about it a little bit? Yeah. So the benefit from a developer perspective is if you have NFTs and you want to store them in a way that actually is safe, the first thing you should do is address them with a content identifier, right? Like it would be a very bad idea to address an NFT with something that points to a location, because anybody could swap out what's at that location and replace it with anything they want. You have absolutely zero control. So step number 1, use a content identifier. That's IPFS. And then step number 2 is store as many copies of that content in as many different locations as possible, right? So I would argue, back it up to Filecoin, back it up to your local machine, put it on AWS. Like for IPFS, it doesn't matter, right, where it's retrieving that content. And if you've addressed it by its location, by its content, then you can retrieve it from any number of locations. So I would always argue for like storage layer maximalism, where you're like not locking yourself into anything, right? So, yeah. Go ahead. It's free. It's free, and for a number of reasons, which I can like. So, the way the Filecoin mining rewards work, the Filecoin block rewards work, is that there's a very high incentive for people to store actually useful data. So storage providers on the Filecoin network actually have a strong incentive to store data at pretty much like at cost, which is actually a lot cheaper than what AWS would charge you. So if you look at storageindex.io, it actually gives you the cost per terabyte year to store something on the Filecoin network. NFT.storage is free because it's moving into a DAO structure where basically the DAO has an endowment that funds the perpetual storage on the Filecoin network. Similar, I guess, ultimately to how Arweave works, where also you're funding an endowment that then perpetually renews future storage. So that's kind of how that works. Sorry.
Excellent. I believe we have one more question.
If I use pinning and pin some data, is the location of the data visible to other people and traceable back to me? And if so, could that be used to perform a targeted attack on me?
No, it isn't. The content identifier doesn't point to any location, right? So you're completely breaking free from the client-server model. It is like maybe if you retrieve it, you know ultimately where it comes from. So how it works is basically you ask the IPFS network where, like you say, I have this content identifier, I want to retrieve it. IPFS network then looks up in a decentralized hash table, which is this guy, which is basically like a phone book. So you like have an address and it attaches these 5 peers have that file stored, and then whichever peer is closest to you or specified in what ever way, maybe in a specific jurisdiction or whatever, is the provider that will serve that file to you. So there's no, like, and if 3 of them go down, you still have 2 others to go to. So, like, that's why it's offline first and kind of resilient.
Excellent. And I believe one more.
I know that Filecoin gives a better persistence to the network, right? I understand that.
Yeah.
But you also have a chance to address, since you get a chance to have a product that is focused on that, attack vectors for DHT.
For the DHT itself, so DHT is distributed, right? So it's a distributed hash table. So I'm not sure what, like, there's a. I would. Can you name one? So the Sybil for the DHT does. Let's talk about it offline. I don't really think there is like an attack vector for the DHT specifically around Sybil attacks. But yeah, let's talk about it for sure. Yeah. One more. Sorry,
yeah, thank you for the presentation. So my question is, in general, like, what's the difference between content addressing and data storage? And specifically because most of the time we say, okay, the content of an NFT is stored on IPFS, but so if I just put the content on IPFS, what am I missing? Like, what are the risks?
Yeah, so the way I would say it is content is pinned to an IPFS node and it's addressed using IPFS, right? So it's a little bit like weird, but like that's what I would encourage people to be like sharp around the language. The difference between file storage and content addressing is just like, think about the book example again, right? Just because I can tell you, Harry Potter exists, because I have the name, I have the unique identifier of that book or the ISBN number, doesn't mean that I actually have the book. I just know that it exists in theory, but now you have to find a provider. So, or say or just use an address of a street, right? Like just because there is, what are we, Stralitzer Straße number 2, just because that address exists doesn't mean that the building is still around, right? So having an address and something actually existing is a different thing.
Okay,
it's just a way to reference it.
So, for example, if I put some content on IPFS, so then I have the content identifier, and starting from that content identifier, I can still retrieve the image. It means that someone now is taking care of the storage.
Exactly.
And who is that?
Yeah, so it can be IPFS nodes,
Okay,
right, that you pay, like Pinata, Infura, etc. It can be yourself, if you host your own infrastructure, or it can be any number of people who believe in the value of that content. Oops, it's this slide, right? So it's any combination of these options. You yourself, your own infrastructure of IPFS nodes, somebody that you're paying to host it, or any number of peers that are replicating your content out of the goodness of their own heart or whatever. But none of these are decentralized.
Yes,
Right?
okay.
So that's why a Filecoin comes in.
Got it. Thank you.
Cool. Okay, thanks so much, guys. And
Excellent.
apologies for those slides at the beginning.
Excellent presentation, Lucas.